We've got a socket here that's faulty, so I'm going to show you how to replace it. One side of the socket's working as it should do. But the other side doesn't work. Sockets like this often get damaged, especially when people plug in a double adapter or something and then somebody goes past it with a pram. You've got a good chance of breaking your socket. If that happens, it's going to need replacing. So now I'm going to show you how to replace it. So first of all, we're going to plug that in and switch that on. So we now know that that socket is live. So the first thing we need to do now is go and isolate the socket at the consumer unit. This consumer unit is a bit of an unusual one, and quite a lot of them don't look like this now. They tend to have circuit breakers instead of the fuses. But you can see that someone's wrote on their socket and someone's wrote on their socket. So it's going to be one of those two fuses that controls the socket circuit that we're working on. Really, we need to remove those two fuses. The actual job itself is only going to take a few minutes. So what you're better off doing is just switching off the old consumer unit. But before you do that, you've got to go and check that your washing machine's not running, or your computer, or anything like that, and just switch it off. So we're now going to remove these two fuses. So we'll start by switching the consumer unit off, and then we'll pull that fuse out and that fuse out. Now I'm going to remove those two fuses and I'm going to keep them with me so that nobody can put them back in. If you have a modern consumer unit like this one that uses circuit breakers instead of fuses, you need to switch off the circuit breaker for the circuit that you're working on. But now we need to lock it off. So I'm going to use this device, which is specially made for locking off MCBs. So we'll just slide that over there. Then we'll just tighten up the grub screw. And now that's nice and tight on there, we can now put a padlock through there and lock that. And that'll prevent anybody from switching that circuit breaker back on. We're going to stick a label on there saying do not switch on because we're working on the circuit as an extra precaution. So now we're back at the socket and the actual lights have gone out on this tester, indicating that this socket is probably dead. So what we're going to do now is we're just going to remove the screws holding it on. Now we've removed the screws, we're just going to tilt the faceplate forwards. This is an approved voltage tester, so don't confuse this with a multimeter. And this particular model also has an auto test function, which is extremely useful because you can test it before you use it. If your particular model doesn't have the auto test function on it, you need to test that your meter's working before and after the isolation. So we're just going to test the meter now, and you can see that that's working. So now we're going to get the two probes and we're going to test the actual socket just to confirm that it is dead. So firstly we'll test between the neutral and the live. So we'll locate that on the neutral and then touch that onto the live terminal, and as you can see there's no indication there that there's any voltage there at all. So now we'll just check between earth and live, and again there's nothing there. And then just to be on the safe side, we'll just check between neutral and earth, and again there's nothing there. Once you've done the test, you need to confirm that your meter is still working by pressing the test button. So we can be certain now that this socket is dead, so it's now safe to remove the socket and continue fitting the new one. And if you look in there, you can actually see two wires going into each terminal, which means that this is actually part of a ring main. Sometimes you'll only get one black wire and one red wire, and sometimes you'll get 3 if somebody's taken a spur from it. And also, if you've got a modding house, you could have blue wires and brown wires. The blue wires will be the neutral and the brown wires will be the live. But in this particular case, we've got red and black. So now we're just going to undo the terminals. And now we've removed the old socket. Now that's the old socket that I've just taken off, and you can see that the live is at the left and the neutral's at the right, and that's the new socket, and you can see that the neutral's on the left and the live's on the right. So again, in the neutral goes the black wires, or if you've got a modern house, the blue wires, and in the live terminal goes the red wires, or in a modern house, the brown wires. And of course the earth goes into the earthing terminal. So before we put this back on, we need to move the 2 live wires over to that side and the 2 neutral wires over to this side. And also, if you look here, you'll see that we've got 2 earth wires in there, which are coming from the circuit cables, and also an earth wire at the back there, which is supplementary bonding. So all those 3 will go into the earthing terminal. Those 2 will go into the live terminal, and those 2 will go into the neutral terminal. So before you put it in place, it's always a good idea to undo the terminal screws. And to do this, you need a good fitting screwdriver. You don't want one that's too big or too small. So we'll start off by putting the 2 live wires in, because they're the ones that are furthest away. And when you push the cables in, it's important to get them in as far as possible so that there's no copper conductor showing. So now we can put the 2 neutral wires in. When I've come to fit this socket, I've realised that the supplementary bonding wire isn't quite long enough, so I've actually fit a new piece, which is now there. So that goes directly to the back box and is fastened tightly. And now I'm just going to put that into that terminal with the additional 2 earths. And now I'm just going to tighten that up. It's important when you've done something like this that you check that all your connections are tight. So you need to get hold of each wire and see if you can physically pull it out with your fingers. And if you can pull the wires out, you've not tightened them correctly in the first place. So you need to loosen it off, put them back in and tighten it up again. Now before we put this back on, we're just going to check that they are all tight. So that's the socket fitted now. So now all we need to do is put the retaining screws back in. But before we do that, we need to make sure that when we push it back into the back box, we don't trap any wires. I've just removed a bit of the plaster from the top of there because it was sticking out and it was stopping the socket from going back on properly. So we're now going to use the new screws that came with the new socket. So we'll just put one in one side and just get it started. And then in the other side. And I'm checking down the back that none of my wires are trapped, because it's important that you don't get any trapped wires whilst you're doing this. And then you can tighten up the screws. And as you're tightening up, if you just make sure that it's level. So now we can replace the two fuses. Just by pushing those back in. And then we can turn the main switch back on. And then we can remove the do not switch on sign. Now we can test the socket using the socket tester. You can see it's working on that side. And also on that side. And this particular kind of socket tester tells you if you've got the live, neutral and earth the correct way around.